Good morning. Today, I, Jarmandeep Kaur, of group number 63, is going to present the capstone PowerPoint presentation on the topic Remote Monitoring of the Soil Quality Implemented with Internet of Things. The group members of our group are Samanta, Jashan, Jarman, Tushar, and Zahir. And the project has been supervised by Dr. Harpreet Vohra and Dr. Rajneesh Sharma. Now, I would like Samanta to do the further proceedings.
I'll be talking about what we have done so far, what our project is all about. I'll tell you everything about it. Like German told you, our project is based on remote monitoring of soil using IoT. We have discovered that a lot of farmers have problems in the yield of the crop. So what we are doing is we are trying to help farmers. So that aware of the fact that some of the farmers have traditional knowledge of how to determine the moisture and health of the soil, but this knowledge is only reserved to few. Not everyone is aware about it. So what we are doing is we'll be helping farmers to analyze the essential nutrients like temperature and moisture. So now I'll be telling you about what are the solutions that we proposed. So what we are doing is, with the help of sensors like temperature and moisture, along with the help of microcontroller, we'll be analyzing the soil's essential nutrients like temperature and moisture. To measure the soil moisture, we'll be using capacitive soil moisture sensor, and for the temperature, we'll be using temperature sensor. And also, we are using a ThingSpeak server to monitor the data in graphical and numerical format. We need GSM or Wi-Fi network in the field to send the data to the server. Like we know, in the agriculture field, we don't have internet connection. So for that, we'll be using the Wi-Fi or the GSM module. The receiver is built using ESP32 Wi-Fi module, which has access to Wi-Fi network. The data can easily upload it to the ThingSpeak server, and results can be analyzed in the form of graphs. By analyzing the graph, we'll configure the values of temperature and moisture, and we'll be giving the crop recommendation through our website to the farmers.
Now I would like to explain the flowchart of our project. So first of all, the user will enter the required information and submit it at the front end. Then ESP will try to connect to the internet, and if it would get connected, then it will attempt to connect to this ThingSpeak server. And if it would not, then again it will try. ESP will again try to connect to the internet. After the attempt to connect to the ThingSpeak server, again if the connection to the server is like if it would get connected, then the data would be taken from the sensors. And if it will not, then as I've told earlier also, that it will again try to connect to the server. And after reading the data from the sensor, after successful reading, then the data would be sent to the database. And after that, now Jashan will explain the hardware of the project.
My name is Jashanjot and I'm going to explain the hardware part of the project. In the hardware, we have used various sensors, namely soil moisture sensor, soil temperature sensor, to get information from the soil. We have used ESP8266 Wi-Fi module to connect to the internet. And in the voltage regulator part, we have used components like a step-down transformer, a voltage regulator, resistors, and capacitors. Now, let's come to the working in circuit part. In circuit, our circuit is divided into two parts. The first part is the voltage regulator part, and the second part is the sensor node part. In the voltage regulator part, to convert 220 volts to 25 volts, we have used a step-down transformer, which converts high voltage to low voltage. After this transformer, we have used a bridge rectifier to convert AC to DC, followed by a capacitor of 1 millifarad to remove ripples. After this, we have connected one voltage regulator to convert 25 volts DC to 12 volts DC. These 12 volts are then supplied to the sensor node circuit part. In our sensor node circuit part, we take 12 volts from voltage regulator part, and these are then passed to the another voltage regulator to convert these 12 volt DC to 5 volt DC. These 5 volts are then supplied to the node MCU part, to which our sensor like temperature sensor and moisture sensors are connected. To extract the values from the temperature sensor, we have used a 4.7K ohm pull-up resistor. In our code, we have included various libraries like Dallas libraries and one-wire libraries, and also ESP8266 board to get information. Now let's see the outputs. Here are the outputs on the serial monitor of the Arduino. Here are the values of temperature and soil moisture. This waiting part is showing that the ThingSpeak server will upload the values after 15 seconds. That was all. Now the next group member will explain the next part.
Until now, we have achieved our target of successfully aggregating data at our controller, but our next challenge lies in how to process it. Here comes our ThingSpeak server. For this project, we are using ThingSpeak server to aggregate and visualize our data. Basically, to do this, we on our Arduino IDE go to the board manager settings and click on ESP8266 Node MCU. After that, we include the necessary libraries. Each ThingSpeak server is provided with different API key and a channel ID, which we use for reference in our code. It provides us with the concise real-time graphs, which are very helpful in analyzing and understanding. From there on, we can present this data on our website. Now, Tushar will talk about our website.
So we have created a website which is deployed on Heroku, and we will show a live demo in some time. On the website, we can see the 6 graphs of the 6 different values of temperature, moisture, NPK values, pH values, and also we on the website we have used the real-time data of temperature and moisture, and for the NPK values and the pH data, we have used the data set for to show the values. Next slide. So these are the outputs on our website, which shows the 6 different graphs of the NPK value, temperature values, soil moisture values, and which these values are coming from the ThingSpeak server, which creates these graphs in the real time and shows us these 6 graphs. And for the future prospects and for the extension to this project, we can integrate pH and NPK sensor, and also based on the values of the NPK and pHK, we can give them the type of fertilizers they can use for the better soil efficiency. Thank you.
Okay, it was all about our project. Thank you so much.
For the demo, this is our main homepage of the website, and when we scroll down, we can see the of the project. In the bottom section, we can see our aim of project, what was our end goal for this project, and when we go to the monitoring tab, we can see the 6 different graphs of the NPK value, temperature value, pH value,